In this section, we want to finish off California State Standard 22. We've already found the general and term and the sums of arithmetic series, but now we want to look at the infinite and finite geometric series. So we're looking at the blue portion of it today. Our objectives then to find the formula for the nth term of a geometric sequence and to find specified terms of those geometric sequences. Definition again to remind you, a sequence where there is a constant called r, we call it the constant ratio, can be multiplied by each term to get the next term. That's called a geometric sequence. Remember that constant r is called the common ratio, and here's the formula. T sub n, the nth term of the sequence, is equal to t sub 1, the first term, and times, that's a giant multiplication sign, times r, the common ratio, to the number of terms minus 1 power. Alright, so let's find a formula for the nth term of this sequence, 3, negative 12, positive 48, negative 192. Here's our formula. T sub n equals t sub 1 times the common ratio to the n minus 1 power. Let's start out with something easy. First term is 3. Common ratio we can find by dividing the second term by the first, third term by the second, fourth term by the third. We should get the same number all the way through. If we don't, it's not geometric. When we do that, negative 12 divided by 3, we get negative 4. 48 divided by negative 12, negative 4. Negative 192 divided by positive 48, negative 4. So our formula, t sub n, equals the first term 3 times the common ratio, which is negative 4, raised to the n minus 1 power. So that would be finding the formula for the nth term of that infinite geometric sequence. Let's take a look at another example. Again, we're going to need our formula for everything here. Find the 11th term of the geometric sequence. And again, let me remind you, my goal is to get you to memorize this formula. If I only asked for the 11th term on the test, you wouldn't memorize the formula. You've got 4 terms already. You would find the common ratio and keep multiplying 7 more times to find your answer. So I'm not going to ask for the 11th term. I might ask for the 1111th term or the 111th term. So let's start with the obvious. T1, the first term, is 64. Let's look for that common ratio. Should be the same thing we get when we take the second number divided by the first, and the third number divided by the second, and the fourth number divided by the third. It's negative 1/2. Yes, we can have fractions for our common ratios. To find the 11th term then, it's t sub 11 equals 64, the first term, times negative 1/2 to the 11 minus 1 power. Well, 11 minus 1 is 10. And negative 1/2 to the 10th power, well, anything that's negative to an even power is going to end up being positive. 1 to the 10th power is 1, and then 2 to the 10th power will tell me what I'm looking for. But to save some work, I'm going to write 64, because otherwise I'm going to have 64 times this very large number. So I'm going to write 64 as 2 to the 6th power, because I could see that 64 is a power of 2. I'm going to write 1 over 2 to the 10th as 2 to the negative 10th. And when I'm multiplying, to remember our properties of exponents from previous chapters, multiplying the bases and multiplying the bases are the same, we keep the base and add the exponents. So that's 2 to the negative 4th power, and that's just 1 over 2 to the 4th. And 2 times 2 is 4, times 2 is 8, times 2 is 16. So the 11th term is 1/16. Alright, so that was my approach to that. You could have taken 2 and raised it to the 10th power and then reduced the fraction of 64 over that. But I thought this approach was a little bit easier. So let's move on to another example. The second term of a geometric sequence is 24. The fifth term is 3. Find the 7th term. Sounds like a problem we did that required 2 equations when we did something like this in arithmetic sequences. Second term is 24. Fifth term is 3. So from that, we'll get 2 equations. 24 is the first term times the common ratio to the 2 minus 1 power, because 24 is the second term. That's one equation. Next equation is 3 is equal to the first term times the common ratio to the 5 minus 1 power, because 3 is the fifth term. Let's simplify those 2 equations. 2 minus 1 is 1. 5 minus 1 is 4. We have two equations with two variables. And again, we're going to try to solve them the way we did in chapter 4. And one possible thing here is to do substitution. If we take this blue equation, 24 is t sub 1 times r. And if we divide by r, t sub 1 is 24 divided by r. Then in the other equation, where we see t sub 1, we'll replace it with 24 divided by r. And if we solve that, we'll know what r is. So let's continue in that process. R to the 4th times 24 over r. One of the r's cross reduces, and that's 24r cubed. Divide both sides by 24. So r cubed is 3/24 or 1/8. To find out what r is, take the cube root of both sides. The cube root of r is r. Cube root of r cubed is r. And the cube root of 1/8 is 1/2. So the common ratio here is 1/2. But there's two parts to these two equations, two variables situations, systems of simultaneous equations. We just found r. We need to find t sub 1. So let's take that blue equation that we started with. 24 is t sub 1 times r. And let's replace r with the half we just solved. Solve this equation, we'll find out what t sub 1 is. So to do that, we'll divide both sides by a half. And again, dividing by a fraction is multiplying by its reciprocal. So we're really multiplying both sides by 2. T sub 1 is 48. Now that I know the formula, t sub n equals the first term, and we found out the first term is 48 in this geometric sequence, times the common ratio, which we've solved as 1/2, to the n minus 1 power. Then we can go on to part 3 of this problem, which was to find the 7th term. So t sub 7, let me replace n with 7 and simplify. 7 minus 1 is 6. 1/2 to the 6th power is 1/64. 48 over 1 times 1 over 64 will reduce to 3/4, and that's the 7th term of that particular geometric sequence. All right, we had an arithmetic mean. We also have a geometric mean. Geometric mean is found by multiplying the two numbers and taking the square root of that result, which is fairly simple here. Find the geometric mean between 4 and 9. Well, we multiply 4 times 9, get 36, take the square root of 36, and 6 is the geometric mean between 4 and 9. Lest we think that's too simple, we're going to ask you to insert more than one geometric mean. Perhaps 2, perhaps 3. Probably an even number to encourage you to use the formula. So let's start by saying, well, 3 looks like the first term in the sequence. I want to insert two numbers between 3 and 24. So we've got the first term, second term, third term, fourth term. Looks like the fourth term, t sub 4, is 24. With that in mind, let's use the formula. T sub n, the nth term, is equal to t sub 1, the first term, times the common ratio to the number of terms minus 1 power. So with that, let's insert that 24 is the fourth term, 3 is the first term. We'll substitute in the numbers we know. So substitute, instead of t sub n, we'll put in 24. Now instead of substituting, we'll substitute 4 in for n, and instead of t sub 1, we'll substitute in 3. All right, let's divide everything after we simplify our exponent. 4 minus 1 is 3. Divide everything in sight by 3. Gives me 8 as r cubed. Take the cube root of both sides. R, my common ratio, is 2. Now once again, that's too easy. Some of you saw that before we even looked at the equation. You could say the 3 times 2, and then that times 2, and that times 2. You could tell that that was your answer. Let's pretend we didn't see that, though. 3 times 2 is 6. 6 times 2 is 12. And to verify it, 12 times 2 is 24. And because that was so simple, and because I do want to encourage you to use this formula and to know it, I will not choose a common ratio on the test as simple as 2. Probably be some kind of fraction. All right, well, that's our closer look at geometric means and geometric sequences for today.